Riverside Flooring is part of the James Halstead Group, and we're a manufacturer of heterogeneous floor covering. We manufacture mostly for the commercial market and also for residential. We have around 60 employees. All the products manufactured at Riverside are sold through Polyflor, another James Halstead Group company, across the world. We have a wide covering of all markets, not just the heterogeneous that we provide here, but homogeneous and also LVT tile. We're quite design-led and we're very active in the market. We pride ourselves on getting material to customer really quickly to help them deliver their projects on time to the highest quality. Riverside manufactured product via Polyflor is supplied all over the world. In the factory itself here, we produce sheet flooring using various plastisols to create a floor with a unique design that we print on the sheet in-house, making up a whole range of products from safety flooring to standard compact flooring to acoustic versions. So all of the products that we produce have a UV coating on, so every square metre of product that comes out of this facility goes through the GEW equipment with PUR lacquer on it. Putting the PUR lacquers on helps durability, can be used to enhance appearance, but very good for enhancing stain resistance. Depending on the PUR lacquer, that helps set the gloss or the matte effect. And it can also aid slip resistance. The UV system that we had in place had been in for a good number of years. That system was coming to end of life, the technology it was built on. And because we now use PUR coatings on everything we make here, we needed something robust that we could use all the hours that we produce in. So when it came to replacing the system, we had 3 different suppliers that we wanted to speak to. We approached the original supplier, and then we also had contact with GEW and asked them to come and discuss the project with us. It's always a very tricky thing, is to take a plunge with a new supplier. You know, you have to be more than 100% sure. You really have to have a lot of confidence to jump and make the change to somebody new. So we really had to think long and hard and do a lot of due diligence and a lot of work with GEW, as well as visiting the factory and talking to the guys and looking at the design to gain that confidence in order to get us to move. It's very critical to us because we're making quite a wide sheet and we have to have certain things in place to ensure that the UV is cured in the right way. It was key for us to make sure that GEW both understood that and demonstrated that they'd done that in the past.
We understood the parameters of the material they were making, the width, the speed, what type of coating they're using, etc., how many lamps there were. But in this case, there's a lot more to it in terms of the functionality and some of the parameters of the finished product, which are very highly influenced by the UV system itself.
We had an option here to do something totally different with different technology that could help us from a maintenance point of view, help us start and stop the line a bit more efficiently, and also create a bit more space in the area where the plant was to allow us to see the sheet more, to help us with any problem solving. So there was really an opportunity here to change the way we did things.
My main task of this whole project was to get the new system fitted within a very tight time frame. From my experience in putting many projects in, you've got to have a relationship with the supplier. Prior to us actually getting any equipment on site, there's been a lot of work done behind the scenes. In order to fit any new system in, we had to basically remove the existing system. That meant that the new system was going to have to work. There was no going back.
Part of the difficulty in trying to cure PUR on a sheet 4 metres wide is there aren't any 4.5 metre wide lamps. So whatever system you put in place, you have to have some overlap of the lamps to cover the width of the sheet.
What happens at the points where the lamps overlap was a particular concern for Riverside Flooring, because if that's not done very carefully, you get a difference in irradiance, in intensity, and the dose, the quantity of energy. And if that happens, then you can get differentials in your gloss level across the material. And if it's a piece of flooring 4 metres wide, then rather obvious to see that once it's installed, and it doesn't look good. Equally, from the UV lamps point of view, they cure under an inert atmosphere, so there's nitrogen that's introduced into the area where the final curing lamps take place. And it was important to make sure that the level to which the residual oxygen in that chamber is reduced is consistent, because again, if it's not, then you get differential gloss matte patterns across the material, which is not acceptable. We sent up some of our specialists to do an audit on the line to measure what is the radiometric profile on each bank of 3 lamps and what's the total dose, what's the irradiance that's produced by these lamps at various positions across the width. And we're looking for how uniform, how consistent it is now. So we probed up the nitrogen chamber there, measured up how consistent the oxygen levels were inside there, and that's our minimum target for consistency of irradiance and dose in our solution.
We did quite a lot of testing on the product, where we looked at lamp overlap and we looked at checking the curing process. We had one of our PUR suppliers involved. They did some independent testing for us, and once we'd established the lamp technology and the setup could deliver what we wanted, we pressed the green light to go.
We did several visits with our technical people down to GEW to see the whole system being built. We looked at the electronics of it, the mechanics of it. Everybody was working together.
The interaction with the technical team was excellent, with the design team was excellent.
The day came, we ripped out the old system completely. That was nearly a 5-day job just to take them out. GEW people were on site. We worked very well with them, put the new system in. A lot of mechanical work, a lot of hours spent.
We hit the deadline, producing grade 1 material on the day we said we would be after the shutdown.
So the present setup today is the coating's applied with a coater to the web rises up another floor level. It passes underneath a gantry with 3 lamps on it. These are 3 overlapping 150 centimetre UV lamps, which forms the pre-gelling station. After that, the web moves to the final curing position, which consists of 3 gantries of 3 overlapping lamps each. All of that area underneath those 9 lamps is fully inertized, so there's a nitrogen-rich atmosphere there which depletes the oxygen down to a specified level to ensure enhanced surface properties of the finished coating.
On the old system, we have to turn the whole system off and then run production to a stop in order to get into the machinery to change a lamp. Something in the region of an hour and a half's production disruption, whereas on the GEW design solution, 10 minutes, we can effectively change a lamp on the run.
We can switch the GEW lamps off and isolate them. We don't have to access the lamps from underneath. We can access the lamps from on the top, so all of the undershielding and everything stays in place. We can pull a cassette out, we can replace it with another cassette, start the lamps back up again. There's no need to wait for the nitrogen to purge through the system.
Which saves us a significant amount of time in production. And that's, for us, reduced downtime, reduced scrap, and reduced maintenance interaction.
The older system was very maintenance intensive from a technical point of view and also from a cleaning point of view. The new system's arrived and both parts of that are dramatically reduced. That time is less than halved. And the technical side of having to change anything out is so much easier.
So previously when we would clean the system, it was very difficult to get into all the areas you needed to clean. We would drop the undershield and go underneath, do the cleaning, move reflectors and be in and amongst the workings, which gave you an opportunity to damage things or catch lamps.
The new system, there is a glass plate between the fume and all of the technical side of the lamps and everything. So none of the lamps, none of the reflectors ever come in contact with the fume. So therefore, it's just literally the glass has to be cleaned. We've ran this now for some time and we have not had any contamination at all onto the lamps or the reflectors.
The contamination can't get to the places on the lamps where it can affect quality. So we've made a real step forward in that area as well.
We mounted the UV lamps above a quartz glass window, and then beneath the window is the inerted atmosphere. So the lamps in the inerted area are separated from each other physically by a quartz glass barrier. So the radiation from the lamps shines down through the quartz and exposes the coating on the material. To keep completely separated any contamination that could be occurring in the factory, we don't actually extract any air from the production room at all. We bring in air from outside the building, which is drawn through a dedicated filter panel and introduced into the UV lamp heads under a light positive pressure, so there's no chance for any contaminants in the air within the factory to enter into the lamp. And then the air from the lamp, the warm air, the ozone gas, is discharged to the outside of the building. GEW provide the supply air fans, the exhaust air fans, and a system of ducting which we designed ourselves and installed to transport the air to and from the UV lamp heads.
Reliability is phenomenally better. We've had phenomenally less breakdowns and we've been able to rectify them very quickly. If we've needed some technical backup from GEW, it's a phone call, and within 10 minutes, quarter of an hour, somebody technical will contact you back. They've probably had a look at the history of what's gone on, and every time they've been able to point us in the right direction, and we've been able to rectify it on site.
We're confident that we are saving the amount of power we were drawing on the panels. The warm-up and the setup time of the new lamps is considerably shorter. So even first thing on the morning, we're not having to switch everything on as early for the product to get ready. So we are definitely confident we're saving. To sum up the project, it's been a very satisfying, successful process. The team achieved its goal on such a big project, a crucial project, that if it went wrong would mean no production out of Riverside. A really good achievement by both GEW and Riverside people working together.